5.6 is an add-on of what we learned in our previous chapter, okay? So we talked about angle bisectors. What does a bisector mean? What's bisect mean? Half, right? Splits it in half. So this right here, this bisector, that line right there, that bisects this angle, which means it cuts it in half, right? So that's why there's those congruent markings there to show that those are equal to each other. Okay? Another thing that we did not learn in the previous chapter is when it turns into a triangle. Okay? When that angle bisects, or when that bisector bisects that angle, it shows that these two lines are congruent to each other, or equal to each other. Okay, so it also bisects that segment right there. Okay, now, forget about the bisector, okay? What are those two shapes that we have in there? Right angles, right? Right triangles. What can we assume, thinking about those now, what can we assume with those? What are the two things we can assume?
The middle's the same.
Shared side is the same, good. Let me get red. Okay, what was the other thing we can assume even though it's not in this one? Shared side and vertical angles, okay? That's not in here, but I wanted to touch base on that, okay? So it has those two triangles that we've been comparing this whole chapter, okay? That's kind of what it's getting at. Moving on to this example here, okay? So it shows us that these two sides are congruent and that we have right triangles, yeah? So thinking about those over there, what's something we can assume? Remember the two things we can assume?
The middle.
Middle line here is congruent, okay?
Right angles.
Right, we have a right triangle, so which one should we check first? Okay. Is the hypotenuse shown?
Yes.
There is one there, but does it have a congruent marking on it?
No.
No, but can we assume that it's congruent? Because we know that these two triangles are congruent. So we know that these two are equal. So it wants us to find the value of x. How do we find that if we know they're the same? If we know that those two sides are the same, how do we solve for x? How do we set it up?
Equal to 180.
Yep, not equal to 180. Equal to each other. Okay, so we have 5x plus 12 equals 8x. Now we have to solve. Okay, so what's my first step to solve?
Divide.
Subtract 12.
Combine like terms, so we want to subtract that 5x over. So we have 12. What's 8x minus 5x? 3x. Now what's my last step? Divide by 3.
4x.
So we get 4 equals x. And all this wanted was to find x. Okay. What if it wanted to know the angle, or the measure of AB? We found x. How do we find the measure of AB? Let me put it in a different color so you can see it. AB is right here. Right. We plug in the x that we just found in for that side. So we would end up getting 32 for that side. Okay? Let's look at a couple more examples. Okay? Here it wants us to find FH. Where is FH at? Right here, right? X plus 3 is our FH. It wants us to find that length, but what does that length include? Has a right angle, but it has x plus 3, right? So we don't know the exact angle yet. What do we need in order to know the exact measure? We need to find the value of x, right? What's the relationship between those two lines? Between x plus 3 and 2x plus 1. They're the same. So if they're the same, how do we set it up? Equal to each other. So we have x plus 3 equals 2x plus 1. What would my first step be? Combine like terms. So I'm going to take this x over, subtract x. So we have 3 equals 2 minus x, or 2x minus x is x plus 1. Subtract 1. So we have 2 equal to x. But it wants FH. Plug it in. Okay, so we have 2 plus 3. So I'm just plugging it into that equation there. And what does that give you? 5. Okay, let's look at a couple more. On number 2, it wants to find MK. Okay, on number 2, it wants to find MK. Where's MK at? Or what stands for MK right now? X plus 15 right here. Okay, so we have to find the value of x. How do we find the value of x?
Set them equal to.
Set them equal to each other. So we have 4x equals x plus 15. We want to combine like terms, so what do I need to move over?
X.
The x, so subtract x. So we have 3x equals 15, and then lastly, divide by 3, x equals 5. But is that our answer? No, why not?
Add 3.
Because we have to find MK, so we need to plug in x to this equation here. So we have 5 plus 15 gives you 20. That makes sense? Okay. Last one here. It wants us to find EF. Where's EF at? What's it stand for right now? Yep, 2x plus 5. What do we...
Like 8 parentheses, like,
No, if you're thinking too much. Another person thought that in the other class, though. Okay? This, all it's telling us with this 8 is that we have congruent sides. So we have congruent sides here. And we know that shared side is also congruent.
so X should just fill in.
So these will be congruent as well.
Shouldn't it
Like
just
we
fill
talked about in the other one. Nope.
Because 8 is.
So what do we do with 8?
Nothing.
And what's it there for?
It's there
Exactly.
to
It's just there to
make-
It's there to show us that the triangle's congruent. So we can assume that those two sides are the same.
But regardless if the 8s were there, we would know it's congruent.
No.
We could figure it out.
We could. But the 8s help us.
They're congruent.
So we want to find EF. What do we do with, how do we solve for x? How do we find x? Set them equal to each other. So we have 2x plus 5 equal to x plus 10.
Can I do X plus 10 equals 2 plus 5? 2 plus 5?
Yes, you can. Yep. So I'm going to subtract x over. So I have x plus 5 equals 10. What's my last step? Subtract 5 over. So I have x equals 5. But is that my answer?
No, because it's where you find the length of the side, so you plug it in.
Right. So we need to plug it into that equation here. So we have 2 times 5 plus 5. What's 2 times 5?
10,
10 plus 5?
15.
15. Big brains. Questions over bisectors? Okay.